So I got a request from one student to do more worked out examples, and I got a request from another student to do 2 specific problems from the homework. So I'm going to do what the second student asked, which will also give the first student an example. So here is one of the problems on the homework. I don't know which one, you'll probably recognize it. I'm going to do the version of the student that requested it, and all of you will have some slight differences. So we want to take the region bounded by this line, x equals 8y, this curve, y cubed equals x, for all y's that are bigger than or equal to 0, that is, the region is above the x-axis, and rotate it about the y-axis. I didn't get that written in, although I did show the rotation arrow. Okay, so, as we get super comfortable at thinking about functions of functions of y, we don't need to do this next step, but maybe now it's helpful. And that is, I just took these 2 curves and rewrote them in the way we're most used to seeing them as functions of x, just by solving for y. And it was real easy to do in both cases. I get a line here with slope 1/8, and then we get this cubed root graph. And I've sketched it over here. You can see kind of a banana-shaped region. Cube root is on top, and the line 1/8 x is on the bottom. I'm going to need to know this intersection point, and so I set the 2 equations equal, the 2 functions equal down here, and solve for y. And it's pretty straightforward. Just subtract the 8y across and then factor a y out, and then we get this quadratic with the missing middle term, so it's really easy to solve. There's actually another solution to this equation, but it's irrelevant to us. That is the negative square root of 8, not part of this problem. But here's the 0, 0 intersection point, and here's the other one, which turns out the x coordinate is 8 square roots of 8, and the y coordinate is the square root of 8. So I'm pretty sure this was on the assignment due Friday. We can actually use either method. If it was due Friday, then we would be thinking only about the method of discs and washers. This one will be washers. If it were due Monday, then we would use the method of shells. But I'm going to use the method of washers. And here goes. We have a nice little formula for it. Let's start there. V equals pi integral a to b. Function on top minus function on the bottom. Squared minus function on the bottom squared. Okay, and hopefully we've identified all the necessary parts. Pi, we're going to go from 0 to 8 square roots of 8. I don't know if we need to simplify that, if it will make our work any easier. And that is, I can take a 2 out of this 8. That is, take the factor of the 4 out and then take the square root. And another way, we can write this as 16 square roots of 2. I don't know if it's any better. It probably doesn't matter in the end. I guess I'll use 16 square roots of 2. The function on the top, remember I wrote the formula for it's kind of generically functions of x, and we're actually going to use functions of y. The one on the top is the furthest to the right. Top goes this direction, and that's the line. So 8y squared minus, and then the function on the bottom is y cubed squared slip a point in there. I made one little mistake. Because we're integrating with respect to y, we need the y coordinate up here, not the x. The y coordinate is just the square root of 8, or if I take the 4 out like we talked about, it would be 2 square roots of 2. Okay, so pi integral 0 to square root 2, 64y squared minus y to the 6th. Okay, there's the integral. That's the Calc 2 part of the problem. To evaluate it, I mean, we could easily do it by hand. We could make some mistakes, especially with a sort of awkward y coordinate, 2 square roots of 2. But you also should know you're free to use your calculator and supply the answer that way. Okay? So we can describe the region either way, functions of x, functions of y. But because we're rotating about the y-axis, and presumably when this problem was assigned, the disk washer method was the only method we knew, so that dictates functions of y. Just for the fun of it, let's use shells. So I want to leave this picture here. Let me do some erasing. In fact, I'll pause it and then I'll clean it up and we'll go on. All right, so just for the fun of it, we'll solve the problem using shells. Because the rotation is about the y-axis, we need to integrate with respect to x. Remember, the axis of revolution and the variable of the integral are opposites in the shell method. And again, we have a formula. V equals, I said, 2 pi. Integral a to b, x. Because this is the shell method, we're going to take f minus g. Because it's the region between two. Is for any x value, the height of the shells is the difference between the functions. All right, now let's fill in the details. 2 pi in the x direction, a is 0 and b is 8 square roots of 8, or 16 square roots of 2, however you like to write it. And then we get an x. The function on the top is the cubed root. And the function on the bottom is the line, 1/8 x. So that is 2 pi integral 0. I'll write it here, just 16 square roots of 2. And then I get x to the 4/3 with an errant mark there. X to the 4/3 minus 1/8 x squared. Remember, there's no product rule. Got to multiply it out. And there's an integral all ready to go. It should have the same value as the integral we identified on the first part of the solution. Okay, and it's not exactly a polynomial with this fractional power, but the power rule works for all the antiderivatives, or, as always, you can use your calculator to find the value of that integral. All right, let me pull up the next problem. So this is the second problem sent in to me. It's virtually identical to the last problem. The only difference is the slope of the line, 6.6. So I can go straight to the solution. It's about the y-axis. So we're going to use the washer method. We're going to integrate using functions of y because it's going about the y-axis. So the volume is going to be pi. Integral from 0. Notice I've solved for the intersection point just like we did on the last problem. And we get kind of an awkward number, but our calculators will have no problem with it. The square root of 6.6. Could probably get a decimal approximation. I'm not sure if doing it so early would create round-off errors that will make your answer wrong. So just leave it as square root of 6.6. And then because it's washer, we have the function on top. Again, top is to the right. That's the line. So we're going to take 6.6 and y and square it. And then we're going to subtract off the bottom function, which is y cubed, and square it. And that integral will do the job. Now let's clean it up just a little bit. Square root 6.6, and then we get 6.6 squared, y squared. Minus y to the 6th. And again, that's an easy integral. It's a polynomial. Raise the powers, divide by the new powers, or pull your calculator out. No shame in using a calculator to get an answer. Okay, there you go. 2 problems. If you have more questions, let me know. One of the students apologized for interrupting my free time. And let me tell you, so you know, this is not free time. I'm a full-time employee of George Fox University. Part of that time is dedicated to helping you. So if you have questions, you ask, and don't feel bad, don't apologize, because I'm not in Newburgh, and because, as it turns out, I'm kind of out in the boondocks and I have limited internet access. I'm also 2 hours ahead of you. So I think I got a request last night at, 10 o'clock, 11 o'clock. I was already in bed asleep. So remember, I'm 2 hours ahead, but absolutely, you are not intruding on my time by asking me a question. It's my job. It's what I'm paid to do. And I really, really want to do it whenever that sort of help is needed. And, because of the time difference, because I'm the nice guy, because this is kind of weird having your professor 2,000 miles away, don't worry about your grade. I can make your grade right. What you really need to worry about, worry's not maybe the best word. What you really need to be focused on is, how do I solve these problems? And if it takes you until, a few minutes after midnight, just don't worry about it. And the homework portion of your grade is going to be okay, as long as you really learn how to solve these problems. All right, I'll post this as soon as I can. Again, I don't have internet access here, but hopefully before too long, I can get some internet access and post this to our website. All right, happy problem solving. Talk to you later.